All right. Hello, everyone. I'm Grant McCarty, local foods and small farms educator up in the Rockford area. Welcome to the 2019 Small Farms Winter Webinar Series, hosted by University of Illinois Extension, Local Food Systems and Small Farms team. We appreciate you joining us for these webinars, and we're going to do our best to begin and end within the space of your lunch hour. This is a pretty tight frame for our educators to deliver in-depth, actionable information. So please understand why you're limiting your questions to a text box at the left during the presentations. I'm your moderator today, and will do my best to make sure our presenters answer them as the time allows. This presentation will be recorded, and Zach will email a link to the archived presentation as soon as possible after this concludes. You'll also find a link for a very short online evaluation of this presentation. And very much appreciate your feedback. This week's presentation is from Dr. James Therry. He is one of our local food systems and small farms extension educators in Grundy, Kankakee, and Will counties. James has a diverse educational background with degrees in zoology, botany, crop protection, and his doctorate is in plant pathology. His specialty is in integrated pest management, but he also facilitates other programs in farm management, horticulture, livestock, and horse maintenance, forage production, soil science, conventional and organic specialty crop production, and beekeeping. Today, James will be sharing with us the key aspects of successful soil health. And with that, I'll let him take over and talk about healthy soil produces healthy vegetables. Go ahead, James.
Thank you, Grant. Thank you for that introduction. Because of time, I'll just dive right into the talk. It will be a lot of, 3 or 4 different topics, nothing in depth. If anybody would like us to talk about in-depth information later on, please give us an evaluation, let us know, because there's just too much to talk about. But this topic about healthy soils, giving rise to healthy vegetables or plants for that matter, is of interest to me in as far as I have a background in plant pathology, and the fact that there is a growing dislike for chemicals is of interest to me. As you very well know, chemicals, the development of resistance to chemicals is increasing, and any alternatives are appreciated. The second thing is, for more than 80 years, we've been told about how to manage soils, and soils have always been seen to be inert, like they are dead. It's a dead entity. But the paradigm shift is now to think about soils as living entities. Anything that has health must be living. Sometimes when we have dead soil, we call it dirt. That's what I like to make that distinction. But anyhow, let's get into the topic here. What's soil health to begin with? So soil is a complex and dynamic biological system, and it harbors a whole lot of organisms that help to convert and cycle organic matter into nutrients. Soil health definitions as per USDA is that it is a functional system that is a living system that supports living organisms that thrive in the soil. And that's a key theme right there. We want to support living organisms that are thriving in soil. And pretty soon we'll see how we actually destroy those living organisms from the agronomic practices that we do. And as we go along, you'll also find out that it is the plant-root relationship with microbial organisms that is really important. And those microbial organisms thrive and survive and multiply because we are applying carbon-rich materials to the soil, and also that we are following practices, and we'll mention a few of those, that slow rather than speed decomposition of organic matter. So, nice diagram here that we have always that's been developed by Natural Resource Conservation Service, showing the soil food web. And as you can see, those of you that can see, at the very basic level, we have plants that capture energy from the sun, and by using that energy, combine water and carbon dioxide to form the carbohydrates, which are the sugars that we eat, and by the growth of those plants, there is lots of material that will end up being food for microbial organisms. The extensive root system you see there, the more extensive it can be, the better the carbon content in the soil. The foliage that you see there, the biomass, again, the more it is, the better. So that at the second trophic level, where you have bacteria, fungi, nematodes, they will decompose those plant materials and unlock the nutrients that plants need. And therefore, basically, and I'll say this again, if those first two trophic levels are not working, then subsequent trophic levels will not be working either. Because at the basic level, if that's not working very well, then there's effect on the subsequent ones. And yes, so the soil quality is affected by the microbial mass as well as the carbon quantity. And soil quality, and I stop saying quality because quality is what we've been saying quite a whole lot in agronomic systems when we think of field crops and all that. We want to talk about soil health. I shouldn't say soil quality, I should say soil health. And soil health is affected by the cropping patterns, and we'll see some of them in a second. And what kind of soil amendments we are using. Are we using anhydrous ammonia, or are we using organic material to amend the soil? And then what kind of tilling practices are we using out there? Are we building a resilient soil? I have a picture here that is showing soil being kept loose, which is a desirable thing in a healthy soil. It's an earthworm right there building its channels, and those channels are great for water movement and porosity for that matter. And then the aeration. Roots need both water and air for proper functioning or growth. And on the left-hand side there, plants can be connected with nutrients by microbial organisms. Can point with whatever, but you see those round things next to the roots. Imagine those to be nodules that have been formed by nitrogen-fixing bacteria. The bacteria are able to fix nitrogen from the air, and this is available to the plant. Meanwhile, the plant is giving the bacteria sugars and amino acids and other nutrients that it needs. So there is a beneficial symbiotic relationship right there. Talking about the root and microbial associations is one great example here of mycorrhizae. These are fungi that have a highly specialized association. Myco means fungi, rhizae would be root. So this is a root fungus. And it's able to supply quite a number of nutrients to the plant while it's also getting something from the plant. Top right-hand corner there, you see a plant that has been grown. The two plants are grown in similar soil conditions, but the right-hand side plant has been added mycorrhizae, and you see the growth difference there. The second plant there, or the second figure there, shows a plant growing, and then the right-hand picture of it is showing the association of the rootlets with mycorrhizal fungi. And in the lab, you can bring in some of those rootlets, and the blue dye picks up the hyphae or the mycelia of the fungi. So the mycorrhizae improve drought tolerance in such plants when they grow in soils that are healthy. And we'll continue talking about healthy soils. And the other thing is they also reduce or ameliorate, actually reduce disease establishment of pathogens such as Fusarium, Pythium, and Phytophthora, and those of you that are familiar with them know these to be ones that cause root rots or damping off, and they affect all sorts of annuals that we grow, the pepper that we grow, or the seedlings that we start growing. So mycorrhizae are beneficial in suppressing diseases. And yes, the question might come in later, where do you get mycorrhizae from? In nature, they are available, but you can also buy them to amend your soils. Another picture here. In the soil, and I already said it, you have microbial organisms that can convert organic matter. Organic matter is anything that was once living, the leaves and the roots of plants and animals that die, all that. They can convert those into nutrients. So here you see the earthworms. The earthworms are great at chewing organic matter, and their droppings, which we call vermicompost, have lots of nutrients. And then you see some fungi there of the actinomycetes group, and the actinomycetes will also decompose plant matter into nutrients. And ultimately, what we want is a great diversity of microbial organisms, especially bacteria and fungi. With a great biodiversity of these, then we know that we have greater capability to work on the vast amount of organic matter that is in the soil. Diversity is important. Last week you had companion planting, I think, topic, and that encourages microbial diversity because different microbes are attracted to different types of crops. So that helps, and in a minute we'll be talking about crop rotation, which also enhances microbial diversity. And yes, you can also inoculate. You can buy inoculants of microbial organisms. Certainly you can buy nitrogen-fixing bacteria and inoculate those. You can buy mycorrhizae, that kind of thing. So what are the benefits of biologically active soils? If you have improved soil structure, which is referring to soil tilth and aggregation. With good soil tilth, the roots of crops are able to grow better because the soil is loose, it's not compacted. And with the right aggregation, the soil particles bond together in such a way that there is pores or spaces, that's what I want to say, air spaces, and that water can also be in those pore spaces. And you get better growth of roots, and we just saw that the more roots we have, the better. Okay. So biologically active soils have better water infiltration and holding capacity. When you drive to wherever you drive and it has rained 1 inch of rain, you notice that there's lots of water on the farms as you drive. That's because there's poor water infiltration, because there's compaction beyond 6 inches or so. There's there's no infiltration. And then your soil, if it has good health, should have water holding capability, just like a sponge. And it ends up with healthier plants. And we're using healthier plants ambiguously here because they could be healthy because they don't have disease, which is correct. They could also be healthy because of the vigor they show. They're vigorously growing plants. All that, and they are providing available nutrients and phytohormones and being affected by fewer pathogens because of their vigor and capability. The picture on the bottom right shows rather poorly aggregated soil or strongly aggregated soil on the left, while the soil on the right-hand side is of good aggregation because you can see the root system is growing much better. Keep on going. A biologically active soil does indeed infect insects, nematodes, and microbes. That word is being used loosely so because soil cannot infect a microbe, but it has the components that will affect those insects and nematodes and microbes that we don't want in the soil. We'll talk about that in a second. Biologically active soil has microorganisms that will compete with the bed, fungal, and bacterial pathogens. Pathogens are disease-causing organisms. We'll talk about that also. And the microbes, because they're being supported by these plants, secrete plant growth stimulators. And we'll see the importance of that in a little while. Yes, those are the growth stimulators that are secreted by these microbial organisms, phytohormones, ectoenzymes, and volatile compounds. We'll mention them again. So what are the characteristics of a healthy soil? Thinking about it physically. In unhealthy soils, and I'm talking about the crusting of the soil that you see in the picture there. If you have unhealthy soils, after a rain, you see the soil cracking and crusting. That's a bad soil, needs work, needs to be amended, needs to be made healthy and productive because this is poor soil. Needs to have the kind of porosity and air spaces that you see on the top right-hand picture so that the particles stop aggregating too much, like you see in the picture there. And then it's well drained, of course. That's why we do raised beds so that we can drain our soils better if that's a poorly drained area. That's one of the reasons we do raised beds. It has to have low bulk density. Bulk density, I can explain that by saying that a brick, which is actually made of soil, has very high bulk density. It lacks air spaces, it has no porosity in it. And the chemistry between the soil particles has also been changed. They are bonding differently. The aggregation there is so strong, you can't even break it. So low bulk density will mean the soil is nice and friable and has nice tilt to it and crops can grow easily. Then what about chemically? For most crops, we want our soils to be as close as possible to the neutral pH. A few crops will want it different, but most crops closer to neutral pH. And of course, optimal amounts of nutrients. And then the cation exchange capacity should be high. If the soil is binding on to the minerals that a plant needs so strongly, then that's not a healthy soil. And that happens quite a bit with clay soils. They bind so strong onto the elements that plant needs. And then high levels of organic matter plus stable humus. Humus, just think of it as completely well done compost. And then it's free of toxic compounds, the pesticides that we apply there. And even the anhydrous ammonia and NPK is not that great where microbes are concerned. Characteristics of a healthy soil, again, in summary, should be water absorbing, water retaining, and well aerated from a biological point of view. And in it, the more numbers you have of beneficials, the better. And we're talking both microscopic ones that you can't see and macroscopic ones like earthworms that you can see. And that the plants are rooting appropriately, no dead end for root growth. Later on, we'll be talking about tillage, radish, which is very aggressive when it starts to grow in poorly compacted soils. But even it will get to a dead end where it will start heaving out of the soil or start growing sideways. I've seen this happen. And then you have earthworms. Earthworms are an indicator of good soils. Indeed, if you were to dig like 1 cubic foot of soil and you find 10 to 12 earthworms at least, then you know you have good soil. And like I said earlier, the earthworms are developing channels in soil that are good for porosity and pores. And then they also convert some of the organic matter into nutrients that plants can take up. And yes, we're talking about carbon farming. If you have to develop healthy soil, let's think about carbon farming from now onwards. A plant captures light energy to convert carbon dioxide and water into carbohydrates, and in the roots delivers those sugars down there that can then be used by microbial organisms. And in the process, the dead roots there and any leaves that are dead are converted into carbon, and carbon stays there until we start turning over the soil. And we'll talk about tillage in a second. So the more carbon we have, the more microbial growth we are supporting down there. And once you have a lot of microbial growth happening down there, then we are achieving the goodnesses of soil health. Now, how do the roots support microbial organisms down there? You can see that the roots are exuding all these materials that who have been listed on this slide. But the sugars and the amino acids stand out as nutrients that are of immediate need to the microbial organisms. Again, with soil improving practices, carbon, you can't go wrong with having an accumulation of carbon down there. And the living roots feed the soil food web, and they build the aggregation and porosity in the soil down there. And then with vast rooting systems, you're increasing the biodiversity. We've already talked about that. And then it's promoting the optimal soil structure. And that soil structure is a keyword, again, considering the physical, chemical, biological things we just talked about. And if you can reduce compaction, less of tractor moving over your field, or you, when you've already just done your little garden there and you start stepping in there with your shoes, you're also causing compaction. When we turn over the soil, we have a lot of evaporation taking place, but water never takes salt with it. So especially for people who are in high tunnels or in greenhouses, salinity could be an issue, so you have to manage that. And many more things that need to be done to improve on soil health. I just put this cartoon over here just because Rodale Institute is one institute everyone should be going to check on their publications and other information that they have on their website regarding soil health. They've been studying soils for the last so many years, more than 30, 40 years. And here they have this cartoon where they're saying human nutrition and health starts in the soil, which plants draw their nutrients from. I have a grower here, near here, who is actually saying his nutrition starts from the leaves because he actually feeds the plant, the above ground part of the plant, so that the plant in turn feeds the soil. And when he told me that that's what he's doing with these pepper plants and making $80,000 a year from an acre, I couldn't believe it. But he's using fertigation. He is actually fertilizing the leaves, and the plants then fertilize the soil, and things just happen. Now, that is anecdotal evidence. I don't have any literature to report to you about, but he just told me that's what he makes out of an acre. It was unbelievable. Up to Rodale Institute, they've done a 33-year-old study in which they have compared conventional and organic ways of growing soybean as well as corn. And maybe you might say, well, the left side of that figure shows the soil organic matter between 3 and 5. The bottom there shows time from 1981 to 2014. That's 33 years. And in that time, they have shown that it's been consistent that soils that had manure applied to them or are grown with legumes, which fix nitrogen, had consistently higher soil organic matter compared to conventional systems. 3.5 or just anything over 3 when it comes to soil organic matter is not bad. But what we are seeing is that the microbial communities in the manure and legume planted fields is way much higher. And that you are building topsoil, you're growing topsoil in decades rather than in centuries. The reports out there say that 1 inch of topsoil takes about 100 to 500 years to make. But in Rodale, they're saying you can do this way much faster. So good things. Soil health is useful. There's no question about it. What can we do to improve it? All these things, which I'm going to discuss one by one in subsequent slides, with the exception of managing the residue. Field crop growers on a large scale do amass a whole lot of residues that on the ground. Sometimes they think it's an issue and maybe they don't decompose as fast, and there are ways now they can deal with that, like adding some amendments there that will allow bacteria to break that down faster. But for most small-scale farmers, that may not be an issue. So we've already talked about managing air and water in the soil. If you amend the soil properly, you get porosity as well as movement of water in the soil much better. We'll talk a little bit about using tillage wisely, and then feeding crops with biologically friendly fertilizers and growing more microbes in the process. So biological soil amendments differ from all other amendments that are used to fertilize the soil in that they are alive. or they are made from biological soil amendments such as compost and manures and other types like biosolids or even vermicompost were once from living organisms, and they improve soil quality as well as soil health. They are great, especially if you're doing heavy tillage operations. If you are messing the soil structure that much, you might as well be supplying, spoon feeding this soil as much as you can, because you really are messing up a whole lot of things. The microbial life in there, even the macroscopic life in there, as well as the porosity and the air spaces that we talked about. So you better be using quite a whole lot of the biological soil amendments in that scenario. What's compost? You're all familiar with what compost is. That's how to make it. It's shown there on the slide. But compost has actually been shown to suppress disease, and it improves the physical, chemical, and biological properties of a soil. And in the process, increases the diversity of microbes. And like I just started off by saying, been shown to reduce the incidence of disease. So therefore, by increasing the organic matter in the soil, we are improving soil structure and moisture retention quite a bit. And I forgot to say that in the Rodale experiment there for 33 years, although yields of the two crops, both in conventional and the organic sites, were more or less similar, not identical, but similar, the profitability in the organic system was way much more. One, because there are fewer inputs and you're getting your inputs from elsewhere. But secondly, they found that there was 1.5 times increase in yield during times of drought, coming back to the point that healthy soils do hold water much better than unhealthy soils, so to speak. On the use of compost, I just should tell you that you need to check with your state, find out what are the laws on using compost or manure, all those biological soil amendments, because there is a critical amount per year that you're allowed. And then Rudy is working with USDA in Arizona, did an experiment where he amended soil using compost. And this high quality fungal-driven compost was applied to the orchard that you see on the right-hand side at a total of 10 tons per year. I think he did this for 3 to 4 years. The soil before he came in, he said, was heavily disturbed. So his goal was to get it to a healthy situation. There was no microbial diversity. There was no plants growing on top here, as you can see. It was all unhealthy, so to speak, bad. And in time, he was able to improve that soil. This picture here shows you what happened after a heavy rain. The soil would crust and crack. And again, this is not desirable. But at the end of his experiment, he was able to convert that orchard to look like this. So not only was he applying organic matter in the soil, he also started growing a cover crop, and we'll talk about it in a second. The cover crop, as you see here, is Bermuda grass. And though he did not get like dramatic increases in yield, which he actually did get some, he was able to show that with fewer inputs, the profitability was increased. And the nut quality was also increased, as you can see here. Let's talk about crop rotations now. The story is told of George Washington Carver way back in the beginning of the last century about him telling cotton growers who are rotating cotton on cotton on cotton to break that cycle with growing peanuts in between. And lo and behold, the peanuts fixed nitrogen and the cotton growers found their yields increasing. So crop rotation has been around for, the concept has been around for quite a while. And chosen well, you can improve and maintain good soil health, you know. And if you're mixing your plants between those that are shallow rooted and deep rooted, the extensive rooted ones will give you way much more root mass, whereas the deep rooted ones will penetrate the soil to allow water and air and break compaction to go down. And then you can also select plants that may have high residues. You will very well be managing pests and disease problems, because when you bring in a host plant, a plant that's not a host to a pathogen, you reduce that population of that pathogen. And so crop rotation works well in reducing the pest populations as well as disease issues. Broad-leaved plants tend to have higher residue. I should say that here, the peas and all that, beans, tomatoes. And Cornell University recommends that you can rotate. There's an example given here. The legume crop, fixes nitrogen, which will be useful for the sweet corn if you grow sweet corn. And the legume taproots can be long. The other day, last year, I uprooted a crowder pea, and it had like 2 foot long root. So those ones are great when it comes to that. And that's why they are also very drought tolerant, the beans, because they have longer taproots. They will not wilt as fast as other crops. So plant sequences that promote healthier crops. So sometimes some of the crops we grow, like mustards, can promote health in the soil in that they suppress some of the pathogenic organisms in the soil. And then some sequences will just aid in suppressing weeds, the broad-leaved weeds or the fast-growing plants, I meant to say, can suppress weeds. And in another setting, we can talk about how you can suppress serious weeds like Canada thistle using say, sorghum. Okay. All right. So in your crop rotation systems, you get the advantages of modifying the hard setting and surface sealing of soils. You can reduce compaction. You can aid in nutrient retention, and some of the soil-borne diseases and insect pests are also reduced. Yes, and surface residue, whenever you have surface material residues on top of the soil, that can very well reduce the crusting that you see up there. And of course, it's organic matter in itself, and it's a mulch. And using wise tillage, you can always incorporate it in. And this is very well provided by the cover crops that we want to talk about right now. What are cover crops? Cover crops is any crop or plant that you put in between your crops that you grow. During the off season, Mother Nature never leaves the ground bare. We like to behave like Mother Nature. So cover crops are plants that you grow between crop growing seasons. What cover crops should you grow? It all depends on your farm situation. Do you have too much of erosion going on? Do you want nitrogen fixation? What do you want to do? And to pick on the best option, you want to go to the Midwest Cover Crops Council website, which I've given over there, and they ask you questions. What crop are you going to grow? Where is your location? What soil type might you have? All those questions you fill in spreadsheet and they come out with a recommendation right there. On the right-hand side there, you see tillage radish, which can go 2-3 feet down into the soil as long as doesn't hit a dead end, an end it can go through. And you can see that it's heaving out of the ground because it really actually did hit a hard pan. That's why it is heaving out of it. It still wants to grow, so it's heaving out of the ground. And this cartoon is from one of the companies that is selling radish seed, and it shows how radish can be as useful as a cover crop. You start growing it, and the third picture there shows you that it is absorbing nitrogen. Well, to grow it, it needs the nitrogen. That nitrogen would otherwise have leached into lower levels of the ground, so it's sequestering the nutrients. Now, if you grow this crop 40, 50 days before the last frost in the fall, it will then die. It is killed by winter, by cold temperatures. The N is now available for the next crop next year. Meanwhile, you have the aeration taking place and water getting into deeper levels of the soil. And so this cover crop is really helping that way from a nutrient point of view. The other way that radishes have been shown to be helpful is through reduction of disease pathogens in the soil, as well as nematodes. The leaves of radishes contain what is called glycosinolates. Now, if the leaves are shredded and immediately incorporated into the soil so that the release of isothiocyanates, which is what results when you shred the leaves, the glucosinolates release the biofumigant, which are isothiocyanates. That then needs to be tilled under immediately, and that has been shown to be a suppressant of many soil-borne pathogens. And I bring you back to this one just to remind you that if we are not taking care of the first trophic level and the second ones, those first two, the subsequent ones will not work as well, and you're not going to have a healthy soil. Just a reminder. Tillage, the impacts of tillage, and I'm not going to read all of them over there, but by tilling, why do we till anyway? We are tilling the soil so that our crops can grow better, we can incorporate fertilizer better, and we have better seed to soil contact and better soil aeration. But in the process, we are doing all these bad things. We are causing compaction there. The last point there saying we are planting weed seeds. Remember that soil is a weed seed bank. Therefore, you just brought the weed seeds from lower down, even though you weeded the top. You just brought some new seeds to the top. And so if we can do no-till, or if we do minimum till, which is also called strip till, which is not very well shown over there, or if we do wise till farming, we reduce the tilling, and that should retain the soil structure. Remember, we want that. And the cover crop biomass production will be better. We will have less loss of organic matter and soil moisture and fewer weed seed problems. Now, the cons, I want to take away the soil compaction over there. I don't know why I put it down there, but if you don't till, you have less of compaction. If you have less tillage, you have less soil compaction. It's not a disadvantage, but you have those other disadvantages. Nothing is always has a beneficial. You always have the disadvantage as well. So how can you reduce the inversion tillage that we talked about, which is caused by those types of plows, the mold board, the disc and chisel plow? You turn over soil, you warm it up. And when you warm it up like that, then you expose the organic matter. Now there's warmth and heat, sometimes extreme heat. You make the bacteria work harder and you have faster decomposition. That's not quite desirable. The microbial life is not going to increase as much in that situation. And the soil structure is being messed up. So what can you do? If you're working your garden manually, use this weed cultivator, which only kind of hits the top ½ inch or 1 inch, and you're not going to go that deep. If you're using a tractor, use this shallow cultivator, which really goes only like 1 inch or at max 2 inches, disturbing as little soil as possible. It's really the alternative. How do we suppress the seed? And I'll talk this very quickly in about 4 minutes. Let me begin by saying that of the microbial organisms that are pathogenic, they are way less than 10% compared to the good ones. If we left the situation as is, the good guys would take care of the bad guys. Because they have antibiotics that they provide. They have volatile substances, the good guys, that stimulate plants to produce their own antibodies. There are microbial organisms that eat others. Biological control is either parasitism or predation. It's also being outcompeted. If we are more than 90% good guys, surely we should be eating more than less than 10%. And then also with the root microbe association, if you have all those mycorrhizae shielding the root from the bad guys, then there is inhibition. And then some of these microbes that may affect the plant could induce resistance, which could then be used against the same pathogen. And then all these hormones that are listed on the right-hand side actually do promote growth of a plant. And so if a plant is being promoted to grow much better, then it is vigorous, it has vigor. Trichoderma is listed over there as one of the beneficial microbe that is great when it comes to out-competing the bad guys or even predating them or parasitizing them. And it is sold commercially, as you can see there, Soil Guard or Root Shield, and it's a great one. So how does suppression of disease in a general way happen? So you got your very good healthy soil, which you applied compost down there, as you can see, and then maybe you had a cover crop like hairy veg, which fixes nitrogen, and whose mulch, after it dies, is great on the soil. Your microbes thrive, and you've got lots of them. And they have this, they start secreting all the plant growth promoting hormones that we just saw a while ago. Meanwhile, predating and parasitizing and out-competing the bad microbes, they actually allow the plant to have a systemic acquired resistance should any pathogens try to attack the above ground or even the below ground parts of the plant. This suppressiveness is a study, has been studied for a long time. The caveat here is that there's a lot to know yet. There are people who even say that it doesn't work. I've seen in the literature where somebody said this this suppressiveness of soils doesn't work for me. It's not a silver bullet, but it's got to be done right when it needs to be done. And so I needed to add that it's not always working. And it's not also working for all pathogens. Some pathogens are just difficult. And this was another example, Brassica, seed meal, Brassica, the mustards. The mustards are great, by the way, at reducing disease. It's been observed that apples that are planted where previously there were other apples get what is called apple replant disease. And if you replant in that area the new apple seedlings, if you plant them with the Brassica seed meal, you will have a better crop of apples, and they're not going to be affected by those soil inhabiting pathogens and nematodes. And the Brassica seed meal is so that the USDA people did experiments with is shown right here. So soils that are healthy can suppress soils, and that's a kind of a summary over there. Less disturbed soils with high organic matter, high diverse and high quantity of microbial organisms. But those being the biotic components, there are also abiotic components that also influence how soils will be suppressive of disease. And those also need to be considered. We've already considered organic matter, the soil organic matter, SOM. And because of time, I think, is this my last slide? This is my last slide. Let me stop here.
Okay, well, thank you, James. We've got some questions in the chat box. One of the first questions is, when it comes to the tillage radish, when do you till under the radish leaves? Is this done in the springtime?
Yeah, okay. It's got to be on living radish. So that's in spring. And you want to do this before they flower. Or just some amount of flowering. You see maybe 80% flowering, and before they start seeding, because you don't want that to be weeds, you don't want any weeds, so you don't want the flowers to get into the seed production. So yes, at blooming time.
Blooming time, okay. How do you incorporate cover crops into the soil without tillage?
You can't.
You can't.
I don't know how. And somebody on the asked, maybe Zach knows, but I don't know how you can do that without incorporating them. The alternative is, of course, if it's hairy veg or some other cover crop, is to just mow it down. Those of you that are not organic, burn down with glyphosate. Those are the two things I know of. Otherwise, incorporation has to be, with healing.
And you would, to chime in here too, you would also have some cover crops that winter kill, and so that would help you keep from tilling action, though you still may need to incorporate some.
You just reminded me that with radish as a cover crop, you don't need to bother because it's already underground. The root system is the big part of it, so that will winter kill. Thank you, Grant.
Let's see. Susan's question, does turning over soil with a shovel, say 4 to 6 inches, does it have the same adverse effects as if you were to till?
In certain ways, yes. You just brought up weed seeds that were way down there to the top. And by the way, when it comes to no-till and all that, which is another topic we could probably talk about, if I was to start a new garden on a sodded area on my lawn, the first time I have to till deep because I want to get rid of all the roots or the grass. It is in subsequent tillages that I want to be minimal or just strip till or just till around where I'm planting, that kind of thing. And maybe in 4 years, if you find that your soil has compacted again and you have thistles that now have all these roots going down there, you can go back to the tillage down deep there. So yeah, tilling under with the whole, the disturbance may not be as bad as when you are doing chisel plowing or moldboard plowing, and maybe the earthworms are able to remake their home with all the tunnels and so forth. But remember, you're also bringing organic matter to the top. That will also be prone to faster degradation, which is undesirable, because you want this to go slow so that the microbial, the mineralization takes place at a slower pace so that it can last longer for the plants, maybe even into next year.
Okay, great. So a follow-up question about if you were going to till the cover crop under, would it just be like the 1 to 2 inches of tilling it under?
Till the top 1 to 2 inches? Yeah, that would work. If you can till it 1 to 2 inches, I would say, I don't know the answer, but why not? At that level, if you're covering it and the soil is warm and enough for the bacteria to do their job, they'll do the job. Yeah.
We've had someone ask about activated biochar. Have you worked any with it or know much about it? What is it and how is it used?
You can also chime in, but biochar is a product of anaerobically burning wood. If you burn wood and don't avail oxygen to that wood, the final product is charcoal. That's where the char is from. That charcoal is supposedly good for absorbing nutrients. I am not so good at that one. I don't know much more about that one.
I know Ajay Nair with Iowa State has a lot of information on biochar and some of his work.
And we have a professor too, U of I, who is, I think he's trying to get a whole lot of people joining a biochar podcast discussion. I haven't joined it, but biochar is supposedly very good, especially if you have sandy soils, which where you're losing so much of nutrients. For amending the sandy soil is supposedly very good. I don't have too much information on that.
Someone asked, when you're describing, say, heavy clay, what do you kind of mean by that?
Okay. Clay soils, and maybe, did I say heavy? But clay soils have their disadvantages. If you know Play-Doh is actually clay. And if you had clay that is really heavy, then you have Play-Doh, so to speak. And what does that heavy clay do? It does not allow water through, and it then binds on to nutrients in a way that it doesn't release that as well. And I think the point I was making there was, when it comes to ionic exchange capacity, minerals that a plant need are charged, and the clay is also charged. So the attraction of these two bind each other together. So the minerals are not available to the plants. So when you apply compost or manure or any of these biological soil amendments to clay soil, you're ensuring that the water holding capacity is improved, and that the minerals that are held in that soil are more available to the plants. And I think the heavy clay is probably what I was thinking about if I said heavy clay.
Okay, great. So what might be, an ideal process for converting a scrubby, neglected field to vegetable gardening? One that maybe has weed issues and so forth.
Okay, first of all, so scrubby, neglected field. First of all, so it's looking scrubby in itself. If it's been neglected and it looks scrubby, it is really bad. That means even Mother Nature cannot colonize that area because it's probably very poor in terms of nutrients. It's probably very rocky. It's probably just lots of sandy stuff. It's bad. Okay. You have to till it. There's no question about it. Loosen the soil. If I was doing it, I would loosen the soil if there's lots of soil. If there's lots of soil plus lots of rocks, I would get rid of those because those won't let crops grow as well as they should. And then do a soil test. A soil test will let you know what you have in that soil and what you don't have. And then if I'm organic, then start making friends with the horse owners because they give you the manure for free or the compost for free. I have a place here I've been told to go with a truck and get as much as I want and start amending that soil as much as I can. If I am conventional, then NPK or anhydrous ammonia or whatever, I'll have to start adding that. And then determine what crop I'm going to grow. And the first year I could do a test and grow anything and see how they grow. These days, well, there are some farmers that I talk to and they say, when I grow the crop and I look at the product, I can tell how good this soil is. It gives me an idea of how much amendment I should do. So that's what I would do. But when you say scrubby and neglected, if I was to visit with you, seeing it would let me know much better what's going on. Our garden behind our extension office, I always wondered why it was so bad when I first came here. But I was told, what? Any houses built around here or anywhere, what's the first thing they take away? All the topsoil, which took so long to build and that was the best for cropping, was taken away. Now, to get it back, you have to buy it back. So those types of information are best when one sees it.
Okay, great. And we had I think our final question today, because we're a little bit over 1 o'clock. What part of the mustard plant functions as the biofumigant?
Oh, okay. It's the leaves. It's the leaves. First of all, you didn't grow it. You grew it. See, this one you grew it because you want to suppress pathogens in the soil. It's not one that you grew in the fall to amend the compaction in the soil. So this one, you're not waiting for the root to grow real big. It's the foliage that you are after because that's where the glucosinolates have accumulated. And once you shred the leaves, as in mowing, the glucosinolates then convert into the isothionates, which are now the biofumigants, and which have to be incorporated immediately. You cannot wait for too long. You want to incorporate that into the soil because that's where you want the action to be taken. So it's the leaves.
Okay. Great. Thank you, James. I've done some work with the biofumigants and the mustard. So if people want to email me, they're more than welcome to, because you're exactly right. You got to convert it. You got to create that action and disturbance for the compounds to work. So we're going to wrap up today. I'd like to thank our presenter, James Theory, for joining us today, local foods and small farms extension educator, Ngurendi Kankakee, and gosh, I forgot your third county. I'm sorry, James. For this fabulous presentation, sharing his expertise. I'd also like to thank everyone for joining us for this webinar. I hope you got some good information that will help you in your small farm endeavors, hopefully even some you can put in place yet this winter. Please look for an email from us with a link to the archived webinar on the Illinois Local Foods YouTube channel, as well as a very short evaluation of the webinar you've just watched. We do look at your feedback, and it really helps us shape our future webinars. And with that, I wish you a good rest of your day and a productive growing season in 2019.